Alright, welcome to a video on segments that intersect circles. I'm just sitting here waiting for Supernatural to start, because that's what I do with my summer. Definitions. Sorry. A chord cuts from one side of a circle to the other in the interior of the circle. Secant is a line that intersects a circle in 2 points. A tangent is a line that intersects a circle at exactly 1 point. It does not go through the circle, though. It just touches the outside. And the external segment is the part of a secant segment that's outside the circle. So it's part of the secant, it's the bit that's outside the circle. So here's a picture of all those. In red is the chord. It's inside the circle. And the chord can be your diameter. We see the secant in the blue and purple. Those are together. The purple part's the external part of the segment, and the secant's the whole thing, and then the tangent is just touching the outside at 1 point on that circle. So there's your definitions, and then here's a visual representation of them. And we're going to use these to make some theorems. We're going to use those theorems to solve some equations. So if we hop over here to our first theorem, it's the segments of chords theorem. So we're going to be dealing with chords. It says if two chords intersect on the interior of a circle, then the products of the segment lengths are equal. So that means that if we take, I'm going to use different colors, AE, so we're going to take AE here, and then multiply it by BE, so we're on the same chord, and we take the two parts of that chord, it'll equal the multiplication of the other two parts of the other chord. So we're going to use this, I should probably color that in purple. We're going to use this to solve some equations. So we jump over here with our two examples. I'm going to do the left and I'll have you do the right. So we have to take our two segments. So I'm just going to color them with different colors so we can see the two different chords. And then we'll take the two segments from those two chords. So we have the red chord and the blue chord. So the red chord, we're going to do whenever you do this, I highly suggest when you have the variable, you put the variable second. So we're going to do 15 multiplied by x equals 6 multiplied by 5. Now in this case, we can just do 15 multiplied by x to get 15x, and then 6 times 5 is 30. You always want to simplify both sides first before you start moving things to the other side. And now it's just a simple one-step equation where we divide and we get x equals 2. So now we're going to look over here on the right, and you're going to do this one on your own. And I want you to make a note that this is an x plus 1, which means you're going to have to do some distribution. So if your x ever has anything added, subtracted to it, make sure you put it in parentheses over here. Like I could have put this in parentheses, but I didn't have to. That way you know to distribute. So go ahead, pause the video, and work on that now. Alright, and here's my solution to that. So go ahead and check your work with mine. Make sure we both did alright. And we're going to move on to the next theorem. So our second theorem is called the segments of secants theorem. So we have two secants here. And if the two secant segments share an endpoint outside a circle, so like in that picture they share A, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segment and its external segment. That's a lot of words that mean this simple equation here with multiplying. So again, I'm going to go and change the colors here. So we take AB, so we take the external segment, and we multiply it with AC, which is the whole segment. And that's going to equal AD, so the other external segment, multiplied by the whole secant segment. And those are equal to each other. So like before, we're going to use this and we are going to solve some problems with it. So we're going to solve these for x. I'm going to do the one on the left again, leave you to do the one on the right. So we have our two secant segments, and I'm just going to color in the external ones so we can see the difference. So let's start with the top one, the 5 and the 3. So we're going to take the external segment. Sorry, my allergies are acting up. Got a coughing fit, so I'm going to just kind of start over. So we're going to use the top segment. So we take the external segment. So we take the 5, and then we're going to multiply it by the whole segment. Now that whole segment is 5 and 3. So we're going to have to do 5 plus 3. That's going to equal the other external segment multiplied by the external plus the interior part there. So 4 plus x. So we have to do a little bit of simplification before we can actually get to our x. So 5 plus 3, that is 8. And then we're going to distribute here, because we can't add together our 4 and our x. So 4 times 4 is 16. 4 times x is 4x. And then 5 times 8 is 40. And we don't get to do anything to the right side. So now we can just solve this like a two-step equation, because it is. So we get 24 equals 4x. And then we divide by 4, and we get that x equals 6. Okay. So now I want you to use the same idea. Work on the one on the right here. So go ahead, pause the video, and do that now. Alright, so here is my solution to that. Go ahead, check your work with mine, make sure we both did good. And after that, we're going to move on to our last theorem. Sorry for the honking. One of the students is going by house and honking at their friend at another house. So I think that's the second time you probably heard that. So, segments of secants and tangents theorem. If a secant segment and a tangent segment share an endpoint outside the circle, so again they're going to share the same point, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. God, that's the last one I have to read. So, if we take this tangent segment, so this right here, this is the tangent segment, and we square it, we multiply it by itself. Then we take the external segment, and then we multiply the external segment by the entire segment. Then we get an equation that we can solve. So let's go ahead and get this taken care of with our last examples. Okay, so again, I'm going to do the one on the left, you do the one on the right. So it's the tangent segment squared on the left. So we identify the tangent segment. Here's our tangent segment. So we're going to do 7 squared on the left, and it's going to equal the external segment multiplied by the whole thing. So again, we have to do a little bit of distribution. And then 7 squared is 49. 5x plus 25. We can subtract the 25 here. And we get 24 equals 5x. So this is going to be a decimal, and that's okay. And then we get x equals 4.8. 4.8. So okay, go ahead and try the example on the right on your own. Pause the video and do that now. Okay, so here's my solution. You could have done this a little bit differently. Like I added the 1 and the 8 here to get a 9 before I distributed. You could have distributed first, as long as you distributed to everything. And that's totally fine if you do it that way. So go ahead, if you have any other questions, you got to ask me. But if you're done, try your hand at some practice problems.